We're in the room. Okay, so what we're doing is we're revising linear equations, and we're also looking at the basics such as what? Collecting like terms. What else are we doing? Simplifying indices. We're doing all of these things. Now what I'm going to do is in this case, can Tristan, can you tell me what are the like terms in part 1A?
7m.
7m.
5m.
Yep, so is there anything else that's like?
2n.
2n.
Minus n.
All right, let me just do this. Okay, so that's so what you're saying then is you're collecting the m's. So if I've got mandarins and nectarines, is that how I'd say it? Mandarins and nectarines?
Mandarins.
Nectarines. Okay. Then I've got to collect those. If I had 7 mandarins plus 5 mandarins, I have 12 mandarins. If I had 1 nectarine and I subtracted a nectarine, how many nectarines do you have? 1. So the answer is 12m plus n. Can I get a show of hands, those students that collected that? Now, what's that called? Collecting like terms, and you've been doing that since year 7. Part B then. Kayla, can you please tell me what the like terms are here? 10AB, and that's like with 3AB. Excellent. And of course, what's left over? We've got 11 bananas minus 12 bananas, if you like. So, Lachlan, Duke, what's the answer then, please?
13AB minus B.
13AB minus B. Can I get a show of hands, those students that got that? Good. Everyone? Pretty much? Good. Okay. Now, if you're not, what I want you to do is with the highlighter, is I'd like you to put a highlight and actually highlight where you went wrong. Joel, what are my like terms for part C?
You've got negative 11. Oh, no, sorry. The 2 squared.
So V squared Z?
Yeah.
Now, you need to have, the pronumerals have to be exactly the same. What about, Joel, if I had VZ, would that be, if I had 2VZ, is this a like term as well?
Not with the same.
No, it's not a like term with this because we have to have exactly the same pronumerals. So I can only collect the same and add them. For example, it's easy when you've got like B. I can say I've got 11 bananas. I take 12 away. I have negative 1 bananas. Well, it's the same over here. How many V squared Z's do we have? 13V squared Z. How many, now if I erase this, okay, can you tell me how many Z's do we have? How many Z's do we have, Jenna?
25.
We don't have 25. Now, I thought that some students would do that. Now, let me explain why. Negative 11 plus negative 14. Now, what students do is they think, oh, a negative plus a negative is a positive. That is incorrect. What we can do is let's do a number line, okay? This is our number line, all right? What goes in the middle of our number line?
0.
0. Okay, so let's say that 0 is here. Now, if I have negative 11, let's just say that's over here. If I'm subtracting 14 from a negative 11, which way are we going? Are we going left or right? Left. So if I'm going left, how could I possibly get a positive number? Does that make sense?
Oh, I did get negative 25. I just saw the negative.
Okay, so there you go. So it's 13V squared Z minus 25Z. Can I get a show of hands, the students that said plus 25Z? Did anyone write plus 25Z? No? Good. All right, answer to the next one. 5 times 4, we multiply the constants out. 5 times 4 is 20. The answer is 20B. Pretty straightforward, I would say. 4A times 3B, we've just done indices units, so that's 12AB. Now, what about this one? We've got a 3 times a 5 times a 4. Now, 3 times 4 is 12. 12 times 5 is 60. However, I've got 12 or 15 times negative 4. What's my result? Is it going to be positive 60 or negative 60? Negative. And the reason why is if they're the same, if the signs are the same, what can you tell me about the result? What's the result if the signs are the same? I've just written it there. What's the result? Are they positive or negative? They're positive. So think about signs, but this is only for multiplication, ladies and gentlemen. Multiplication, not addition. Okay, that's what the point I was trying to make before. This is a very important fact that a number of students still make the mistakes, even though we've been doing it since year 7. A positive times a negative, though, or a negative times a positive, is going to be, we know, is going to be negative. Okay? Now, we can't keep making this mistake. Okay? We'll keep drumming it into your head. But 3 times 5 times 4, negative 60. What am I doing when I'm multiplying two indices of the same base? Can you please tell me what am I doing to these? Yes, Michael. A to the power of 1 plus 1 is 2, and we've got b to the power of 1. Can I get a show of hands, the students that got this one correct? Okay. Jackson, did you get that? No. No, what did you do? Did you get the 60 correct?
No, it's -6.
Negative 6. Okay, so what you need to do is 3 times 5 times 4. Just worry about the sign. All right. So he's dropped off the 10. I'm not sure what happened there. Okay. But we've all got, a few of us have done a fair few different things, but I'm only going to tell you what students, what mistakes they tend to make. What about here with this one? What can I do with these t's? Joel, what happens with these t's? T divided by t is what?
It's just cancelled out.
Just cancel out. So I can cancel those out because they're multiplied. All right, so I'm going to do that. And I'm left with 10s over 6. Can someone tell me, Tristan, what is 10 over 6 as a simplified fraction? 10/6, but can I simplify that? What's the factors of 10 and 6? 5/3. So can you explain to me, what are you doing when you say 5/3? What am I doing?
Dividing them both by 2.
Good. So you're dividing the numerator by 2, and the numerator and the denominator. So now what that means is s stays the same. 10 divided by 2 is equal to 5. 6 divided by 2 is equal to 3. And the s doesn't just drop off. The answer is that in simplified form. Can I get a show of hands? The students have got that correct. So you didn't get that correct, guys? Zach, you did? Spiros? Spiros, get off the computer. You're playing around. Give it over here, actually. Bring it over here. Get your exercise book and you can copy this out. Go get it. Okay. 24ab squared. Now, first of all, when we've got the divide by symbol, let's write it like this, negative 8a. Okay, now, can someone tell me, forget about this negative sign here. You can just forget about it for the time being and deal with it later. 24 divided by 8 is what? 3. So what you need to do is deal with that constant first, because it just makes your life easier. Let's go 3ab squared over 8a. Oh, actually, the 24 over 8 is 3. We've got a. However, a positive number divided by a negative number is a negative. So that negative doesn't drop off. Now, are we finished yet? No, you need to simplify. What can I do, though? Can you tell me what I can do? Darcy, what can I do here to simplify this? Darcy, looking up.
Yeah, sorry.
Tell me what I'm doing. Look at the board.
Cancel the A's out.
Cancel the A's out, thank you, because they're multiplied, aren't they? Okay, so the answer is what? 3b squared? Negative 3b squared. That negative doesn't go anywhere. Okay? Answer, can I get a show of hands that got that correct? Did you get that correct? You don't have your sheet? Well, bring your sheet.
So,
Yeah.
my brother said that you could do 3b squared over a, and I was like, what?
No, don't worry about that. That's wrong. Okay, let's write this out. 10m times 4mn. Let's write this one out. Over 8mn. Jake, tell me, what are you going to do to solve this? Can you explain in words what you would do?
Times
10 by 4, which is?
40.
Good. 40 divided by 8 is what, Cooper? Yeah, 5. Thank you. Okay, so what do? We actually write 5 first of all. We've dealt with our constant. All right, now 5. Now what I'm going to do is m times m is what, Jackson? M times m is m squared. Thank you, Jackson. M squared as a numerator, and then the n just doesn't drop off. Beautiful. What about, and that's over mn. Okay, can someone tell me, Tenny, what can I do now? So Tenny's saying that we can cancel out the n's.
And also
One of the m's. So that's going to be equal to 5m. Is that correct? All right, can I get a show of hands that students that got that one correct? Zach, you didn't get that correct?
No, I made a silly mistake.
You made, what was your mistake?
I don't really know. I think I divided the 8.
Can I ask what you got?
Oh, 1.75
1.75m.
What?
Now, for the record, Zach was well and truly above 90% on his recent assessment. I hope you don't mind me saying that, Zach. So he's made a silly mistake, but can I just say, no decimals, please. Leave them in exact fraction. What is 1.75 as a decimal? Can anyone tell me? Oh, sorry. What is 1.75 as a fraction? Can you tell me that, Kayla? 1 3/4, which is in an improper fraction. We're talking about the numerator bigger than the denominator. 1 3/4 is what as a fraction? 7/4. Don't ever do rounding off to decimals in algebra unless you're asked to, please. And that's right. Now, if you show your working, Zach, then I could have perhaps given you a mark. All right, let's keep going. Now, this one, did Mr. Bowers go through distributive law with you last lesson? Because I asked him to, so that's good. Now, yeah, I know he did because he told me. Now, distributive law. What it means is, Lockie, Mr. Hadley, minus 2, what it means is minus 2 times 2x. And it means that minus 2 times minus 4. Now, we did this question together. What was the first line in your working? So, minus 2 times 2x is?
2x plus 2x.
Yeah, no, so minus 2 times... That's all right.
Negative 2x plus negative 8.
Okay, so we've got minus 2 times 2 is minus 4x. And then minus 2 times minus 4 is?
Not minus 8.
It's positive 8.
Sorry, yeah.
Positive 8. And then we've got minus 3 times minus 3x is what?
Positive 9x.
Just think about it. A negative times a positive.
Sorry, negative.
Negative 9x. That's the one. That's the one. Because we went through this one. And then negative 3 times 5 is?
Positive. Negative, sorry.
Negative 15. Now, when I went through this with Lockie, he got everything right, except he got the signs wrong for all of them. However, Lockie, if you go, and this is for all of you, okay, you can see over here, this is the most important thing we're talking about. All right, I'm going to zoom in. Whoa, that's massively zoomed in.
Whoa.
Whoa, that's big, isn't it? All right. A negative times a negative is a positive. Think about this. Same. 2 negatives are the same? Positive. 2 positives are the same? Positive. When they're different is when it's negative. Okay? You just have to remember that, guys. It's just something that...
So, can you show Kate
What?
the answer?
Yeah. All right. So anyway, this is we've got to work out. Some of us need to work on some things. But anyway, that's your answer. But can we simplify it? Maybe. All right, how many, Jackson, what are my like terms here? I'm looking at this line here. What are my like terms?
4x and 9x.
Good. How many of them do I have? Just think about, get rid of the negatives. 4 plus 9 is?
4 plus 9 is
13. Negative 13x. Okay? Beautiful. And 8 minus 15 is negative 7. Okay? I don't know. This thing's doing... I've got to pause this video. Oh, actually, my thing's stuffed up. What's going on? We're back in the room. Okay, over here, what we need to do then... What we need to do then is you need to use distributive law again. What we're doing is 2 times x plus 2 times 3 plus 3 times x plus 3 times 2. Then we have to simplify. 2 times x is 2x. 2 times 3 is 6. 3 times x is 3x. And 3 times 2 is 6. I collect my like terms. The answer is 5x plus 12. Over here, this was negative 7. Sorry, guys. Wait for what? Well, write it down. You were supposed to do this sheet. It was homework. Yeah, okay. 5x plus 12. You can watch the video if you miss out on something, or you can ask the person next to you. All right. Now, did you have this stuff? Did I ask you? Did you guys do this sheet? Okay. I'm going to keep going then. All right. Now, identify the errors in these expressions and then write out the expansion. What has happened? What's wrong with this 2x plus 6? Tristan, what's happened?
So the first one.
Yeah? What's wrong with it?
Although they haven't used distributive law from 2 times 6.
All right, I'm going to put this microphone near you, Tristan. Can you say that again?
They haven't used the distributive law for 2 times 6.
Beautiful. So 2 times 6 is? 12. Thank you. 12. All right. So what about over here, Zach? What's happened with this one? What's wrong with this?
What's the question?
Well, what's wrong with this?
Oh, this one. Oh, hold on. This should be negative 12.
Should be negative 12. Why? Because negative 3 times 4 is negative 12. Okay, I'm not going to write that down, but that's what you should have got. Okay, what about this one, Lockie? That's part C. What did you think?
They
Sorry, wrong Lockie.
didn't do the minus 3x. It should be minus 6, not plus 6.
Okay, excellent. So what Lockie is saying is that it is actually negative 3 times x. Negative 3 times x. We're looking at here. Negative 3 times x is negative 3x. And negative 3 times 2 is positive 6. This one, is negative 6. Okay? So once again, there's been 2 mistakes there. He hasn't dealt with the positive. He hasn't dealt with a positive times a negative. And also, he's just dropped off this x. Is that lagging too much?
Yeah.
Oh, well, sorry, it's wireless, so you need to give it a break. All right. Gee, the poor computer, what has it done to you? Huh? All right, well, I'm sorry, it's going to lag. All right? Kids these days, honestly. Kids these days. We didn't have this stuff. We had Commodore 64s. You could Google a Commodore 64. All right. How long have we got left, ladies and gentlemen, till the end of class? 15 minutes? Okay. I'm gonna plug away. So we have to. Now, a farmer has. Year 9s. Year 9s. I'm still waiting. Thank you. Write an expression for the total number of heads. A farmer has X pigs and Y chickens. Okay, so given the fact that a pig only has 1 head and a chicken only has 1 head unless you've cut off the chicken and it runs around with its head's cut off. You heard that expression? They do, absolutely. But how many heads are there? X plus Y. Thank you. Awesome. We've got to declare our variables. Write an expression for the total number of legs. How many legs does a chicken have? 2. So considering a chicken is Y, we need to say that a chicken has 2 Y legs, and then I have to add that to how many legs does a pig have? 4 what? X in this case. Thank you. Now that's just writing basic expressions, ladies and gentlemen. But what about a rectangle? Shh. Can I just ask, Alberto, what would you do if you were doing this question? It says draw a diagram. Well, you've got to draw a diagram, but a lot of questions will... Can you draw the diagram for me, please? I'm going to get you to... No, draw it right here, please. I would like you to do it. Alberto's going to draw me the diagram. Draw the diagram.
Alright.
All right. Yeah, you got to get used to this thing, don't you? That's a really ugly looking rectangle.
Yeah. I'll redo it for you.
He's going to redo it. Okay.
Yeah, I'm going to have another shot.
I like the first one of it.
Fair. No, that's better. Is that better, sir? Is that it, sir?
All right, Alberto.
Yep.
I do want to get... It's the weekend. It's Friday.
3x?
Okay. Now, a rectangle's length is 3 times its width.
So,
Draw a diagram labelling length
So,
and width. So,
that's
what's
1 and that's 3.
what's this? Okay. But the thing is, do we know what the width is?
No.
So, what do we use as a variable?
X.
Okay, good. All right,
Okay,
so can you
X.
write that, please? Good, okay.
Yep.
Now, is that 3?
No.
Or isn't it 3 what?
X.
Thank you. All right, it's not that easy doing this stuff, I can tell you. So I think Alberto has just proven that. So don't mock my handwriting, okay, because it's not easy. All right, thank you. That's correct. 3x and x. So this is correct. This is x. This is 3x. Now, why do we have x there? Can Jenna, can you please tell me why we have x and not 1 and 3? Absolutely. Now, it says here, write an expression for the rectangle's perimeter. Show you're working, because if you'd show working, I can give you... I'm going to say that this is worth 2 marks.
2 marks.
All right? Now, if this is worth 2 marks, what can you tell me? I'm going to say that I'm going to declare a variable which is perimeter. And the perimeter is what, Tristan? Can you tell me what the perimeter is?
3x
Yep.
times 2 plus x times 2
Excellent.
equals perimeter.
Awesome. So what he's saying is that 3x times 2, because a rectangle, there you go, they both have to be the same length, don't they? All right, now, we've also got 2 of those. So my perimeter is, and let's do it just so we can do brackets with distributive law and all that sort of thing. 3x times 2, if you like, plus 2 times x, or 2 times x, if you like. So 3 times 2x, so 2 times 3x is 6x, and 2 times x is 2x. The answer is what? 6x plus 2x is 8x. If I add 2 xylophones and I added 6 xylophones, the answer is 8 xylophones. Show of hands who got that correct, please. Can one student to put their hand up and tell me that they didn't get it correct? Is there a student in here that didn't get that correct? Oh, pretty straightforward then, okay. Write an expression for the rectangle's area. Joel, what did you have for that?
So that'd be 3x plus x.
Area is length times width. Now my length remember that the width is this 3x here,
Yeah.
and the length, well, the other way around, I guess. The rectangle's length is 3 times. So this is the length, and this is the width. So can you tell me then? It's 3x times what? And why did we do our indices? Because 3x times x is what, Joel? 3 what? X squared or?
Yeah.
So 3x squared. Okay, there's your answer. Show of hands, the students have got that.
Done deal, bro.
Can someone be honest and tell me that they didn't get that right? Who didn't get that right? Okay, Tenny got 3x times x, which technically is right, but has he simplified? No. Would you get full marks? No, you wouldn't. So what Tenny was saying is he wrote 3x times x. Now, a question would be saying a simplified answer. That's not simplified. Okay? Now, extension. We're going to be doing this. Decide if the following are true. Is A times B, B times A?
Yep.
Yes, it is for all numbers. I can tell you now. Shh. Is that right?
Yep.
All numbers are true. That's fine. What about A divided by B is the same as B divided by A? Is it true for all numbers though? Can someone give me an example of a case where A divided by B is equal to B divided by A? Lachlan Duke. 60 divided by 15 and 15 divided by 60. Okay, now 60 divided by 15 is equal to 4. 15 divided by 60 is equal to 1/4. So that's an example. Can anyone give me an example of a case where B divided by A does equal A divided by B? There is one case. Yep.
The numbers are the same.
If the numbers are the same, thank you very much. 2 divided by 2 is equal to 2 divided by 2. That's correct, isn't it?
Yes.
Or we could say that 1 divided by 1 is equal to 1 divided by 1. Are we okay with that?
Yeah.
Good. All right, so there is one example. What about A plus B and B plus A? Yes, that is always the case for all true numbers. What about A minus B and B minus A? No. Can someone give me an example of that? Of maybe an example where that is correct? Yes, Alberto.
3 take 1 is 2.
3 take 1 is equal to 2.
1 take 3 is
1 take 3 is
negative 2.
equal to -2. So that's a case of it not being... Can anyone give me an example of that being the case?
Zero, 1 maybe?
Yeah.
0, 0, do that.
I won't worry about it for now. I'm going to stop the video there because I think it's gone for too long. I don't want people to be watching a 50-minute video. What we will do though next time is we're going to go through the sheet which is of simplifying and solving algebraic equations. I'm going to stop